This channel has now reached over 100,000 subscribers, which is an absolutely incredible achievement, and we're all so thankful for the unbelievable support we've had here. As a way to celebrate this milestone, we're going to be taking a look at what our planet was like 100,000 years ago, to see what the climate and geography was like, what animals were around, and which human species were living at this time. And yes, we may be a little bit late to this video, but don't worry, if we start working on the 200,000 special now, we should just about get it done in time. Probably. We also have some very exciting announcements about the future of the channel at the end of the video, so make sure to stick around for that. So then, let's begin. The Earth 100,000 years ago. In the first section of this video, we're going to look at a few of the non-human animals that were around or just dying off about 100,000 years ago. For this part, I've selected an example of the most interesting megafauna from every continent except Antarctica, to give a wide overview of what the world's inhabitants looked like. But of course there were many more fascinating animals alive at this point that we just don't have the time to cover here, so apologies if I've left out a particular species you wanted to see. Anyway, here are the animals of 100,000 years ago. For no particular reason, let's start in Asia. 100,000 years ago was a very significant time in this part of the world, due to this being the date of extinction for one of the most fascinating and mysterious primates that ever lived, Gigantopithecus. This giant ape genus was actually a relative of today's living orangutan species, being positioned within the same subfamily, Ponginae, and living from around 9 million years ago through to about 100,000 years ago, when they all suddenly disappeared. The fossil remains that are currently known of this organism are very incomplete, being composed of just teeth and a few jawbones, meaning accurate reconstructions of what this animal looked like are incredibly difficult to produce. Still, a pretty remarkable amount of information can actually be determined from what little remains of these creatures. For example, although it was thought at one point that Gigantopithecus was closely positioned to members of the hominin lineage, specifically being related to the Australopithecus genus due to the similarities seen in their molars, it was eventually realized that this likeness in fact convergently evolved, and the life appearance of these animals may have been more like that of living orangutans. Although, reconstructions of Gigantopithecus as much more gorilla-like have also been suggested, due to an inferred similar lifestyle. The size of the animal has also been calculated from the remains, but due to their fragmentary nature, the estimations do vary quite a bit. The largest sizes suggested for Gigantopithecus include heights of up to 3 meters and weights of almost 600 kilograms. However, the smaller estimates put the weight at less than half this value, and the height at no more than 2 meters. Though this still makes Gigantopithecus the largest primate ever known. Based on the locations where the fossils of this genus have been found, it was discovered that Gigantopithecus would likely have crossed paths with Homo erectus, with direct evidence of their coexistence being uncovered in a cave in Vietnam, in which preserved teeth from both species were located. This allowed paleontologists to conclude that the two ape species lived together throughout East Asia for a significant time during the early and middle Pleistocene. But then, about 100,000 years ago, the giant apes vanished. The cause of this extinction has been debated for a while, but fairly recently there was a study that discovered just what the source of their downfall may have been. By examining the stable carbon isotopes found in the enamel of Gigantopithecus teeth, the dietary niche of these animals was determined. The study found that these primates were suited to living in forests where they had a generalist vegetarian lifestyle, and that, despite what had been inferred in the past, they were not specialized to feeding on just bamboo. It was also discovered that even in areas where there was significant open savanna landscapes, Gigantopithecus stuck to foraging within the nearby forests. It was therefore reasoned by the paleontologists that the large sizes and very specific niche inhabited by the apes was the cause of their extinction, as when their forests became massively reduced during the glacial periods in Southeast Asia, the animals no longer had anywhere to find the food they favoured, and eventually died out. A sad end for such an incredible creature. But hopefully much more complete fossils can be found in the future that allow us to tell even more about how these remarkable primates lived. Next, we journey to North America. 100,000 years ago, you would have seen an incredibly impressive sight in many places across this continent. Herds of one of the biggest of the mammoth species, the Columbian mammoth. These massive animals were capable of reaching heights of around 4 meters or 13 feet, in addition to weights of about 10 tons. Their tusks were huge too, being much more curved in comparison to living elephants, and reaching total lengths of almost 5 meters in the most extreme cases. The teeth of these animals were very well suited to grinding up plant materials such as bark, twigs, grasses and sedges, with ridges of hard enamel on the surfaces of the teeth being perfect for this task. There would have been 4 teeth present at any one time in the mouths of these enormous beasts, but as the structures became worn down over time, they were subsequently replaced by newer teeth erupting below, a process which would have occurred 5 times throughout the full life of these animals, each new set of molars gradually growing to far larger sizes. The extent to which furry integument was present on these mammals is not currently known for certain. However, it is reasoned that Columbian mammoths would not have had fur as dense as that known for woolly mammoths, since they were inhabiting mostly warmer regions than the habitats in Eurasia and more northern America where woolly mammoths were found. Thanks to some incredible fossil localities, namely the Waco Mammoth National Monument in Texas, as well as others, we have a pretty good understanding of the herding behaviour of these mammoths, which is similar to modern elephants in many ways. At this location, a herd of all females and young individuals was uncovered, indicating that these animals, like today's elephants, lived in matriarchal family units. This herd seems to have been killed all at once, leading to suggestions that the mammoths died in a flash flood, or perhaps due to dehydration at a waterhole that dried up. Until quite recently, it was thought that the Columbian mammoth had evolved from the Eurasian Mammuthus meridionalis that moved into North America. However, newer studies have shown that they are in fact derived from Mammuthus trogontherii instead, which likely immigrated into the New World across the Bering Land Bridge about 1.5 million years ago. Interestingly, a lot of interbreeding also occurred between the Columbian mammoth and the woolly mammoth, producing intermediate forms between the two species in locations where they overlapped, leading to some confusion over whether there was actually as much difference as we originally thought between Columbian and woolly mammoths. But more research is needed to properly clarify the situation. Travelling much further south next, we move to South America. Of course, there were all sorts of fascinating creatures alive 100,000 years ago on this continent, but here we're going to look at just one of these, an animal called Toxodon. This genus managed to survive from around 11.6 million years ago in the Miocene all the way until just 5,000 years ago, and the fossils of these incredible animals had quite an impact on Charles Darwin himself when he discovered them and became puzzled as to just what exactly they were. While voyaging on the HMS Beagle during the 1830s, Darwin was able to purchase the skull of a Toxodon species that lived slightly later than 100,000 years ago from a farmer in Uruguay, and his discovery of unique ancient mammals exclusive to South America likely aided in developing his ideas of species changing over time through natural selection. Physically, Toxodon would have looked a lot like a modern rhino, being about 2.7 meters long and weighing almost 1,400 kilograms, with a huge and incredibly robust skeleton that was able to support its large mass. However, they display a number of unusual anatomical features in the skeleton that resulted in Darwin and the man who first named and described Toxodon, the infamous Sir Richard Owen, noting its close resemblance to several different living groups of animals. First, the structure of the mammal's teeth, in addition to how they would have grown continuously throughout the life of the animal, suggested a close relationship to the rodents, which also possessed dentitions like this. But its resemblance to rhinos and hippos was also noted, and Darwin also stated how the positioning of its eyes, ears and nostrils could indicate these creatures were semi-aquatic, likening them to dugongs and manatees as well. More recently though, it's been confirmed that Toxodon almost certainly was actually fully terrestrial, using chemical signatures found in the fossilized bones of the animals to determine that they fed on twigs, leaves and other plant material found above ground level, utilizing its continuously growing teeth to do so. And, also fairly recently, a study was published that at last sheds some light onto what exactly Toxodon and its relatives were. Toxodon belongs to an order of mammals called Notoungulata, which were unique to South America, and for a long time no one was entirely sure what they were. Looking at ancient proteins from the animals, their evolutionary history could be unravelled more confidently, since previous morphological analyses had run into trouble determining what Toxodon was due to all the convergences with other mammals found within the Notoungulates. But, in the end, it turned out that the Notoungulates were actually very closely related to the living Perissodactyls, the group containing tapirs, rhinos and horses. Moving into prehistoric Europe now, let's take a look at a widespread, quite prevalent animal that in many ways embodies the fauna of this region 100,000 years ago, the cave hyena. This animal is currently classified as a subspecies of the still living spotted hyena, called Crocuta spelaea. though it was much larger than its African relative, at up to almost 103 kilograms, or about 227 pounds in weight. As you might expect, it had a much stockier and more robust skeleton, though this probably meant that it was not as good at running as today's hyenas, instead being more suited to dragging away big chunks of dead animals. Fossilized remains of these hyenas have been discovered in many different caves throughout Europe, indicating that the animals were spread all across the continent and even into Asia, from Siberia to the Iberian Peninsula. Interesting discoveries in caves of the Bohemian karst in the Czech Republic have revealed some fascinating insights into how this species lived and what they fed on, with the caves being identified as sites that the hyenas used for dens and prey storage. However, some of these caves seem to have also been used by cave bears for hibernation, and interestingly there's evidence that the hyenas would scavenge on the bears when they died in these caves. Not only this, but the hyenas would also occasionally cannibalize each other, and it was found that the creatures would mark out their den sites using fecal pellets. Some of the inhabited caves were also shown to have given the hyenas a good view over the surrounding lands, due to their positions at exposed hilltops. Analysing the cave hyena remains and the many fossils of other animal species that were also found in the caves from when the hyenas brought carcasses into them, it was discovered that these creatures primarily fed on Przewalski's horses and woolly rhinoceroses. But they also fed on a wide variety of other organisms, including steppe bison, reindeer, red deer, megaloceros, the alpine ibex, and even other carnivores such as the Eurasian cave lion, grey wolves, the previously mentioned cave bears, and possibly even wolverines. They apparently did also eat woolly mammoths too, but not as regularly, presumably due to the scarcity of the mammoths in the karst region. So, these hyenas were pretty formidable animals that would have preyed on or scavenged all sorts of creatures, before dragging them away into their dark caves for consumption. But it's not just these incredible discoveries of physical hyena remains that provide us with a glimpse into the lives of these ancient carnivores, as cave hyenas have also been found depicted in rock art in France. These illustrations indicate that these extinct animals also possessed a spotted coat like their living relatives, giving us a good idea of how they would have appeared in life. Cave hyenas are actually not depicted relatively that much in rock art, however, especially when you consider the huge range they were spread over, leading to an interesting suggestion in a paper evaluating the Upper Paleolithic rock art of these animals, that cave hyenas were low down in the ranks of animals that were worshipped by Ice Age hunters, due to them not often being hunted as prey, not being a particularly dangerous rival like bears and cave lions, and due to them not seeming as impressive as mammoths or woolly rhinos. But that's not to say that humans and cave hyenas didn't interact at all or come into competition with one another, as demonstrated by a specimen of a hyena ulna from about 120,000 years ago in Spain that displays evidence of humans butchering the carcass it originated from. So some humans did probably occasionally eat the hyenas if they had the opportunity. Additionally, there's also some evidence to suggest that cave hyenas would sometimes steal the kills of Neanderthals, and there are signs in certain caves of inhabitation by both Neanderthals and cave hyenas at different times. So these impressive and fearsome beasts would have had quite an impact on the European ecosystems of 100,000 years ago, leaving behind a legacy that tells a great deal about how they lived for us modern humans to discover all this time later. It's also worth saying that another giant reptile was living in this area 100,000 years ago, Megalania, but we've already covered that animal in another video. Quincana was a very unique creature, belonging to a group of crocodilians called the Micosuchians, a completely extinct, diverse subfamily of reptiles that inhabited Australia and the South Pacific. This animal would have been very different to the living crocodilians we're familiar with, since Quincana was a fully terrestrial animal, hunting down prey on land instead of in or close to water sources. These terrestrial crocodiles possessed relatively very long legs, making them better at moving about on land, and also likely meaning they could have been capable of bursts of speed over short distances, making them dangerous predators. In addition, their dentition was different compared to living crocodilians, which generally have conical teeth, whereas Quincana had zyphodont teeth, that is, curved, serrated and compressed teeth that were perfect for the slashing of flesh. The size estimates for the Quincana genus, which currently contains 4 species, vary from about 2 or 3 meters all the way up to a possible 6 meters, though this largest estimate is apparently based on a very fragmentary specimen. The name of Quincana is actually a fascinating story itself, coming from the Quincans, a kind of powerful supernatural spirit from the Australian Aboriginal mythology. These beings inhabit caves and dark places, coming out at night to attack, and since fossils of Quincana were found in caves, the naming inspiration of the crocodilian makes sense, In fact, Quincana would actually have coexisted with Aboriginal peoples for some time, and may have sometimes preyed upon or been preyed on themselves by humans. So, another remarkable animal existing about 100,000 years ago, Quincana was certainly a strange kind of crocodilian and probably a terrifying predator to the fauna inhabiting this region at the time. Finally, we journey to the continent of Africa. Here, 100,000 years ago, some very strange-looking animals were roaming, one of which is the amazing Sievertherium. This genus contains 3 different species, which collectively spread across much of Africa and even into the Indian subcontinent, surviving from about 5 million years ago to possibly as recently as 8,000 years before the present. For a long time, the bizarre-looking fossil remains of Sievertherium puzzled paleontologists, who were unsure of what exactly this animal was, and therefore what it looked like in life. When it was originally described, it was thought to be a representative of a lineage linking the ruminants with the pachyderms, the outdated classification for elephants, rhinos, hippos, and others. This led to some reconstructions showing the animal as a sort of moose-looking creature. However, we now know that Sievertherium is an extinct giraffe, being placed within the Giraffidae family. The mammals possessed some very impressive-looking ossicones that were almost antler-like, as well as a pair of smaller ones just above the eyes of the animals that look more like those seen in living giraffes. Fairly recent body mass estimations of the species Sievertherium giganteum, the fossils of which were found in the Himalayan foothills, showed that these creatures were possibly some of the largest ruminants that ever lived in terms of weight, reaching about 1,246 kilograms, though obviously there would have been individuals that got larger or didn't quite weigh that much. Sievertherium probably fed in a similar manner to today's surviving giraffids, using their elongated necks to access foliage from higher up on trees, presumably in a comparable way to the okapi, which Sievertherium appears to have resembled in overall body shape. So, there we have yet another fantastic animal that was around 100,000 years ago, making up an additional piece of the unique fauna which existed at this extraordinary time in our planet's history. All the organisms we've talked about here so far never quite made it to the present day, though some came pretty close, but thankfully their remains were preserved for us to find, allowing us a glimpse into a lost world that existed relatively very recently in the entire history of Earth, and enabling all those curious animals to live on in the minds of these strange primates.
In this next section, let's take a look at the climate and geography of the time. 100,000 years ago puts us well into the last glacial period. For this part, I'm going to need to explain a bit about how we break down the different time periods during the Ice Age. We are currently in an Ice Age. An Ice Age is simply when the Earth has permanent ice on its surface all year round. So it may not seem like what you would expect, but we are actually in one. Our Ice Age is called the Quaternary Ice Age because it began at the start of the Quaternary period 2.6 million years ago. This Quaternary Ice Age is broken down into glacial and interglacial periods. Within the Ice Age, there have been many of these periods, with the last glacial period ending around 11,700 years ago. That glacial period is known to us British people as the Devensian. The name is derived from the Latin word for people living by the River Dee, Devenses. The reason for this is because there were some particularly well-preserved deposits from the last glacial period found by the River Dee near the Welsh border. The end of the Devensian was also the end of the Pleistocene epoch and the beginning of the current epoch, the Holocene. The Holocene began with the start of our current interglacial period, where we have far smaller and fewer ice sheets than in a glacial one. Glacial periods are further broken down into glacial maximums. Now, glacial maximums are what people think ice ages are. They are when the glaciers are at their peak and stretch far into the temperate regions of the Earth. Although the last glacial period ended 11,700 years ago, the last glacial maximum, when ice reached well into England and Germany, was around 26,000 years ago. So let's apply this understanding of how the period is broken down to the climate 100,000 years ago. Well, we know that 100,000 years ago was well into the 2.6 million year old Quaternary period, so it was definitely an ice age. We also know from various ice cores and other climate research techniques that the last glacial period was from around 115,000 to 11,700 years ago. So we know that 100,000 years ago it was far colder than it is today, with far more ice coverage, but we know that the last glacial maximum was 26,000 years ago, and so 100,000 years ago it was definitely cold cold with far more glaciers and ice sheets than today, but it wasn't at the maximum extent that it would get to in that glacial period. Interestingly, different areas can reach their glacial maximums at wildly different times. It is thought that the northwest Greenland ice sheet reached its maximum extent at only 1,000 years into the coming glacial period. However, it did not stay this way and retreated back to roughly what it is today, then advanced slightly more towards the end of the glacial period before returning to its current day position. This is obviously an abnormality and did not represent the overall trend of the glacial period, but it is interesting to show how quickly the Earth's climate can fluctuate. So it's very cold and rather icy, with ice sheets covering parts of Europe and North America. Ice sheets are obviously made up of frozen water in the form of ice, which means that all the seawater is tied up in the ice and not in the ocean. This obviously meant lower sea levels. However, due to the fact that the glacial maximum was not reached until 26,000 years ago, it is believed that areas such as the Bering Land Bridge were still underwater. It wasn't above water until around 70,000 years ago when the glacial period really got going. The Bering Strait had been open before in other glacial periods, allowing animals to migrate into the Americas, but it wouldn't be for another 70 to 80,000 years that humans would get to the Americas via the land bridge. Of course, geography isn't just about the physical world, it is also about humans. 100,000 years ago we had barely left Africa. The furthest we had reached out of our East African roots was North Africa. At the time in which most migration was occurring, it is thought that the Sahara was far less arid than it is today, making it far easier to cross, with the coming ice age turning it into a desert we know today as moisture was removed from the air by the ice sheets. Humans have been in that region ever since, however it is a different story outside of Africa. 100,000 years ago we had reached the Levant, modern day Israel, Jordan, Lebanon and Syria. However, we didn't stay. It is believed this first group of humans that left Africa died out and another migration didn't occur until 40,000 years ago. It is actually thought that they could have been forced to migrate again at this time due to the drier climate caused by the glacial period forcing them out of Africa. Of course, at that point humans spread like wildfire as far more land was above sea level, creating land bridges to North America, Indonesia and of course Doggerland to Britain. The fact that we got to the Levant so quickly suggests that much of the modern day Red Sea may have been above sea level 100,000 years ago due to the growing ice sheets, that would of course keep growing for tens of thousands of years more and expose even more land to migrate across. The final place that humans reached at the time was South Africa, and like North Africa, humans didn't die out in this area and have been living there ever since. Neanderthals also hadn't reached their full range 100,000 years ago. It is thought at their height they extended from the Iberian Peninsula all the way to Mongolia. 100,000 years ago they were nearing the maximum extent, having reached the Caspian Sea, so they didn't have far to go before they began to die out.
And now I'm going to look at what our ancient ancestors and the other human species were up to at this time. Probably the most important question we have to answer here is what actually were the human species walking around the planet 100,000 years ago? First up, we have Homo floresiensis. This relatively recently discovered human species have only yet been found on the island of Flores, this possibly being the only place they lived at this time. Homo floresiensis has the nickname Hobbit, which, perhaps unsurprisingly, comes from its height. Standing at just over a meagre metre tall or 3'6", it was once thought that the remains of Homo floresiensis could have been as young as 11,000 years. However, more recent investigations have concluded that these humans were no longer present over 50,000 years ago, around the same time modern humans moved into Asian and Australian areas. Given what normally happens when modern humans enter a new area, this has led many experts to believe that it was this event that forced Homo floresiensis to extinction. Little is known about this exceedingly uncommon species of human, but we do know that they did use stone tools to hunt some of the surrounding wildlife for food, including the smallest species of Stegodon, an extinct genus of the elephant family. Another human species that we know very little about is Denisovans. Named after a Russian hermit that lived in the cave where the first Denisovan bone was found, this species of human is not yet to receive a proper taxonomic name, as no one can quite agree on what it should be. While most remains found of Denisovans were uncovered in the Denisova cave, where they were first discovered, a relatively large mandible specimen was uncovered in the Baisha Karst cave in China, showing that they were more widespread than previous evidence would suggest. One of the few things that we do know about the lives of the Denisovans is that, like most other human species, they were no stranger to interbreeding. In fact, Melanesians, Aboriginal Australians and Papouans all have Denisovan DNA, suggesting that their ancestors interbred with Denisovans. Homo erectus is the next human species that was around 100,000 years ago, and it is the first known human species to look, well, human. The name Homo erectus actually means upright man, although there is some debate on different aspects of Homo erectus. For example, whether the species Homo ergaster is the same as Homo erectus or another species or another variety. Homo erectus are also considered to be the first humans to expand to another continent, with evidence of their presence being found in Asia as well as Africa. Evidence of hearths built by Homo erectus suggests they could have also been the first humans to cook their food, and further evidence has also shown that Homo erectus were the first human species to make and use stone axes as tools, a major step in stone tool technology. But despite Homo erectus being the first human species to make all these advancements, they still went extinct. So why? New research done in August of 2018 suggested that Homo erectus could have gone extinct partly due to laziness. The stone tools that Homo erectus used all seem to come from materials that could have been found around the camps and living places that they used, whereas tools used by modern humans and Neanderthals were made of much higher quality stone, some being transported from exceedingly long distances, with some humans from these species even climbing mountains for higher quality resources. It is believed that this laziness, in addition to an inability to adapt to the changing climate, forced Homo erectus into extinction. Whether or not a derivative of Homo erectus evolved into Homo sapiens is unknown. I'm going to give a quick honourable mention to Homo luzonensis, not least because I horrendously mispronounced its name in 7 Days of Science back when its discovery was published in April. Because of its discovery being so recent, this is the human species on this list which we know the least about. The bones found have been dated back to around 67,000 years ago, so while it is likely that they were around 100,000 years ago, we can't be sure. Remains of Homo luzonensis have only yet been found on the island of Luzon, suggesting that this could have been their only habitat. It would certainly explain the height of these humans, which is estimated to have been under 1.2 meters or 4 foot, through island or insular dwarfism. Island dwarfism is what happens when species are confined to relatively small habitats like an island, and they slowly get smaller and smaller as the generations go on. This also explains the smaller size of Homo floresiensis. Now for the second most famous human species, Homo neanderthalensis, or Homo sapiens neanderthalensis. Once again, no one can quite come to a large consensus, with some experts preferring to refer to Neanderthals as Homo sapiens neanderthalensis because they believe that they are a subspecies of Homo sapiens, with others preferring to classify them as a completely different species. Either way, they're certainly different to us, and they're certainly not around anymore. But when they were, Neanderthals looked similar to modern humans, with shorter legs and taller and wider bodies. A lot of research has been gathered about Neanderthals and the large amount of Neanderthal specimens that have been found, and so a lot more can be said about them in comparison to most other human species. So at our time, 100,000 years ago, Neanderthals were living around most of Europe and parts of Asia. It's estimated that it wouldn't have been for another 10,000 years until they reached Siberia. Neanderthals were a hunter species, who used stone tools and fire to more efficiently go about their daily lives. While this certainly isn't the limit of what we know about Neanderthals, all other knowledge is often debated and consensus regarding their behaviour is rarely reached. For example, there had been a long time where even whether or not they were hunters was debated, with some favouring the theory that they were a scavenger species instead. However, during the 1990s, archaeological excavations in Lower Saxony, Germany, uncovered 8 spears, since named the Schöningen spears, after the location of where they were found. The users of these spears are believed to have been Homo heidelbergensis, a human species that is thought to have gone extinct long before our 100,000 year mark. The attributing of the spears to Homo heidelbergensis means that this human species possessed the cognitive and intellectual capacity for anticipatory thinking, which would be needed to hunt. The importance here for us is that Neanderthals are a descendant of Homo heidelbergensis, meaning that they too would have used pre-made weapons such as spears to hunt for prey. So the debate over whether they were hunters or not has been mostly dissolved, but there still remains many aspects of the Neanderthal behaviour which is not agreed upon. There is also much false information about these close relatives of ours, and much of this is behaviours or cultural aspects of Neanderthals that would make it seem like they were more capable of intellectual and symbolic thought than they actually were. This is mostly because media outlets use these as interesting articles, but many of these findings that they report have little direct evidence to the conclusions that they present. For example, in 2012, the authors of a study determined that they had found evidence that Neanderthals had plucked feathers off birds, and therefore they must have been even using feathers as prehistoric personal accessories. This was a very controversial judgment, but news outlets still reported it without the controversies that followed. There is a similar case where pollen from flowers was found on the remains of a Neanderthal in 1975, and it was long thought that they were used decoratively or symbolically at a burial. But now further study, research and analysis has led this theory to be no longer accepted. If you live in Europe, Oceania or Asia, some of your DNA will be from a Neanderthal ancestor, and sure enough, at our 100,000 years mark, modern humans were interbreeding with Neanderthals here in the Altai region of Siberia. Speaking of Homo sapiens, our sixth and final human species here is what is normally referred to as modern humans, with the taxonomic name Homo sapiens, or if you believe Neanderthals are a subspecies, Homo sapiens sapiens. Unless of course you believe the Risu theory, then it's Homo sapiens sapiens sapiens, or if you believe both, the Homo sapiens 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 no, I've gone too far, I'm kidding. Except for the first Homo sapiens sapiens, that part was true. Anyway, if referred to in the context of the modern day, Homo sapiens are traditionally just called humans, because they are the only non-extinct human species still living today. You, me, your best mate, your mum, your dad, your dog, you get the picture. Homo sapiens. Oh no, apart from the dog. Anyway, what were Homo sapiens doing 100,000 years ago? Well, it was previously thought that it was around this time where Homo sapiens started moving out of Africa and into Europe and Asia. But in January 2018, a paper was published in the journal Science that revealed that Homo sapiens actually left Africa much earlier, by around 80,000 years. So for our time period, it is safe to assume that our ancient ancestors had indeed migrated from Africa. Another thing that they were definitely doing 100,000 years ago is one of the most ancient of human practices: art. Evidence has been found in the Blombos cave in South Africa of lots of equipment that is clearly meant for manufacturing paint. Pigments, shells, bits of bones, all of these would be used to make paint, and this would likely be applied to the body, but also could be used on leather materials and cave walls, although the surfaces of the caves in that region do not preserve paint well. Cave painting denotes a higher cognitive ability, and so we can tell from this that Homo sapiens were somewhat cognitively advanced during this period. It is also possible that modern humans in Egypt were actually mining a rock called chert, which would allow stone tools to be of higher quality and perform better. So overall, Homo sapiens were doing pretty well, and setting themselves up to be the dominant human species for millennia to come. So there we have an overview of our planet 100,000 years ago. From the climate at this point, to the strange animals existing then, and to the multiple human species kicking around at the time. We really hope you enjoyed this celebration of our incredible milestone, and thank you all again for the astonishing support you've shown us. But the celebrations aren't over yet. Here's Ben in the flesh to tell you more.
We're very excited to finally show you some of the merch that we've been working on. We've used Teespring to create some really cool items for you all to buy, featuring the Benji Thomas logo as a full logo, like on this shirt, and as a small badge thing like on this one, as well as much, much more. For example, this mug.
We've also got the 7 Days of Science logo on t-shirts and various other items, and, as I know you've always wanted, 7 Days of Socks. Also, this mug is pretty cool. That's hot.
So if you head on over to teespring.com/stores/BenjiThomasStore, which will be linked below, you can see all this stuff and more. We hope you like it. It's certainly really cool to be able to have physical items with the logo on. And eventually we will add some more designs in the future that aren't just the logos.
Anyway, we're also excited to announce that we've set up a Patreon at last, which will be a great way to help us continue to create this sort of content if you wish to do so. We're going to be uploading some bonus and behind the scenes videos over there as a thank you for supporting us, as well as giving people early access to video scripts, the ability to vote on future video topics and more.
And finally, we're delighted to tell you that we now have some more YouTube channels for you to enjoy. Firstly, Ollie is starting a channel based around geopolitics, where he will be uploading all sorts of videos about various topics, including things like breaking down current geopolitical conflicts.
Also, we're setting up a channel focused on history, named after our resident history expert, me. Expert being relative, of course. We already have one video up there which we did nearly a year ago, and plan to be putting out a video a week within the next couple of months, with videos about history, literature, media, and objective politics. It's going to be awesome.
Anyway, Thank you so much again for getting us to this point. We're so happy to be able to make these videos for you, and that you all seem to enjoy them so much. If you would like to find out more about our world, its history, and the wonderful life that surrounds us all, please feel free to subscribe to the channel if you think we deserve it, and if you would like to see more from us.
Wait. One more thing.